Guys, welcome to YouTube channel Foundation JEE. In today's lecture, we are going to discuss about energy, in which we will discuss two types of energy. First is kinetic energy and second is potential energy. Guys, in this lecture we will also see the definition of energy, kinetic energy and potential energy, and also discuss some numerical problem based on kinetic energy and potential energy. Okay, so guys, in our surrounding there are so many types of energies like sound energy, light energy, nuclei energy, mechanical energy, etc. Okay, so here we will discuss mechanical energy. Okay guys, first you see the definition of energy in physics for mechanical energy. How much work is being done by an object to other one object is known as its energy. Guys, kinetic energy possessed by an object due to its velocity is known as kinetic energy of an object. Guys, SI unit of energy is joule. So you can say when an object is in motion, then only it possesses kinetic energy. Okay, now so how kinetic energy of an object is being calculated? So it is work done on object to acquire its final velocity. So suppose a mass m of an object we apply a constant force F, so its displacement say D. Okay, then we can write work done on object to acquire say velocity u to v equal to force into displacement. Okay, here guys we assume force and displacement are in same direction. Okay, so you can say, sir, we know motion equation that v square equal to u square plus 2as, where s is displacement, then we can write it as a 2ad. Okay, now the displacement equal to v square minus u square by 2a. Okay, or you know Newton's second law of motion we have already discussed in our previous YouTube lecture, laws of motion, in which we also discuss second law of motion, which say if a constant force say F is acting on mass m, then its acceleration a equal to guys F by m. Okay, so you can say F equal to ma. Okay, if this one is equation 1 or this one is 2, so in equation 1 you can put the value of F, then here this one becomes what guys, ma into d, which is equivalent to change in kinetic energy. So we can write it as here ma into d, v square minus u square, or here 2a. So a cancel, a is a acceleration here, so we can write 1 by 2 mv square minus 1 by 2 mu square. Okay, so you can see here this is change in kinetic energy. So you can also say how much work is being done on object to change its initial velocity u to final velocity v equal to change in kinetic energy. Okay, so this is the way you can calculate the final velocity of an object. Okay, so guys, suppose here two terms, this one first term or this one is second term. So this one is guys the final kinetic energy of the object, or this one is a initial. This term, if u is 0, then what you say, sir, if an object is in rest condition, then work done on object is totally equal to the kinetic energy of the object. Okay, so see one numerical problem. Question: mass 4 kg is moving with velocity 5 meter per second. Find its kinetic energy. Okay, so answer guys, here guys you have seen just the change in kinetic energy equal to 1 by 2 mv square minus 1 by 2 mu square. Okay, so here kinetic energy is being changed. Okay, so this one is a final short form kinetic energy, or this one is guys here initial kinetic energy. Okay, so here see in this question no work is being done on object, so you can say the kinetic energy of object equal to what coming guys, 1 by 2 mu square. Okay, so here 1 by 2, mass is 4 kg or velocity is 5 meter per second whole square. Okay, so this 2 1 ja 2, 2 2 ja 2, so what you see, this is coming 2 kg into 25 meter square and second square, so you can say this is 50 joule. So kinetic energy of this object which is moving with velocity 5 meter per second is 50 joule. Okay, a question guys based on kinetic energy. A ball mass 200 gram left from top of the tower whose height from ground is 19.8 meter. Find kinetic energy of ball when it passes to top of window whose height from ground is 9.8 meter. Okay, so solution guys, here question is guys, see this one is a window, okay, or this one is a tower, suppose this one, or someone left the ball from here, here height is given 19.8 meter, okay, or this height is given 9.8 meter, okay. So you guys to find out the kinetic energy of ball at this point, okay. So how you will calculate, okay. So guys, here see this ball is initially here, so what velocity it gained when it travel here to here. So you guys to first calculate what is the distance covered by this ball here to here. So distance traveled by ball to reach top of window equal to 19.8 meter minus 9.8 meter, so this is 10 meter, okay. So you guys to calculate the kinetic energy of ball at this point, okay. So you know the motion equation that v square equal to u square plus 2g s, okay. So guys, when ball left the top of the tower, then its velocity will be 0. So u initial velocity equal to here 0 meter per second. Now g is 9.8 meter per second square, this is acceleration due to gravity, okay. Now we put the value here, so v square equal to 0 whole square plus 2 into g 9.8 into displacement is 10, okay. So you can say sir this will come 196 meter square and second square, so v equal to 14 meter per second, okay. Now energy of ball at this point equal to kinetic energy at top of window equal to 1 by 2 mv square. So kinetic energy equal to 1 by 2 into 200 divided by 1000. Why? Because you need to convert into kg or SI unit or velocity. Guys, here v square equal to 196 or v equal to, you can say 14 into 14, okay. Now see these two cancel 100, or then you can write 196 into 100 divided by 1000. So this is 19.6 joule. Okay, so you can say when the object just crossing the top of the window, this is the window, then its kinetic energy equal to 19.6 joule. Okay, now see another question. A question, guys. A ball mass 2 kg was moving with velocity 5 meter per second and work done on it was 119 joule. Find its final velocity. Okay, so solution, guys, just you see work done on object moving with velocity u to acquire velocity v equal to change in kinetic energy. Okay, so you can next write here how much work is being done. So 119 joule. Okay, or this one will be equivalent to 1 by 2 mv square minus 1 by 2 mu square. Okay, so next we can write 1 by 2 kg mass, v square is final velocity, 1 by 2 into 2 or initial velocity is this one, so this is 119. Okay, now this 2 cancel out, so you can write this 2 cancel, also 2 cancel, so v square minus 25 equal to 119. So v square equal to 119 plus 25 or v square equal to 144. So v equal to 12 meter per second. Okay, so you can utilize this formula, this one, for finding the final velocity of an object when question is like this one. Okay, now next we will see the potential energy. So potential energy possessed by an object due to its shape and position is known as its potential energy. Okay, guys, here we discuss potential energy of an object due to gravitational force. Okay, now first you see how an object can possess an energy due to its shape. Suppose you have a one fixed point, or this is a second fixed point. Okay, or now this is a bow. Okay, now suppose you have made a thread it, or now this one is an arrow. Okay, when you push this in down direction, suppose this shape becomes this one. Okay, so what's happened, this is now in tension. Okay, when you release it, then the arrow will move. Okay, so due to the change in shape here, this shape to this one, the potential energy is being created in this bow. Okay, so potential energy here, how much work is being done on object to achieve a certain height is known as potential energy of that object. Okay, guys, you remember that potential energy possessed by an object does not depends upon the path traveled, or you can say here, suppose this one is a earth here, suppose this one is a mountain, or one ball is here. Okay, so how much work is being done to reach the ball, suppose here this one is a ground. Okay, or this one at height h from the ground, so it does not mean how you go here to here. Okay, it is equal to how much work is being done on object to achieve a certain height is known as potential energy of that object. Guys, when this ball is suppose initially here and go from this position to that position, then you need to work against the gravity. Okay, so how much work is being done against the gravity is known as the potential energy of that object. So how much work is being done against gravity to achieve certain position, here we are talking height, is known as potential energy of object. So it does not depend upon path traced. Okay, suppose this ball is here or this is now here from earth surface. So if you will go like this one or here, so the height is h, so work done against the gravity in direction of force equal to force into displacement. So force against the gravity is mg. Now d is h, then this is mg h, because you know this force and distance or displacement in same direction, because see this ball is here, then gravitational force is acting in this direction, or if you are going in this direction, so in direction of force here net displacement is h, so this is mg h. Okay, so now see one numerical problem for your understanding. A question: a ball mass 5 kg was thrown up direction with velocity 5 meter per second. Find maximum potential energy possessed by ball. Okay, so solution guys, suppose this one is ball here, you thrown it up in this direction, so how much work is being done against the gravity is equivalent to potential energy of the object. So potential energy of object equal to how much work is being done against gravity. Okay, this potential energy equal to mg into h, because here force into displacement, force due to gravity is mg in down direction, ball is going in up direction, so you are doing work against the gravity. So here you have to need apply equal force, so we are assuming mg is force acting in up direction, or now h is height, okay, which is here d. Okay, so if we apply here this formula also, fd cos theta, so you also know when displacement and force are in same direction, then theta equal to 0 degree, so fd cos 0 degree, or this is fd. Okay, so this is mgh. Okay, now so you know motion equation, V square equal to U square plus 2G H, okay, or when the ball attain the maximum height, then final velocity V becomes 0. So at that time H will be maximum because it will not go further up, okay. So 0 whole square, or this is 5 square, or this is 2 into 9.8, or this is, guys, H. Guys, here see, I did one mistake. Here the value of acceleration has a negative sign. Why? Because see, the motion is in up direction, or force acting on this one is down direction. So this is equivalent to G. So force is acting in down direction, means acceleration is acting in this direction, or motion in up direction. So when time passes, velocity decreases. So you can say the force is decelerating the object. So acceleration and velocity has a different direction. So if we assume V in up direction positive, so G is negative in down direction. So you can say this one H equal to 5 whole square, or 2 into 9.8 meter, okay. So this one is a maximum height attained by the ball, okay. So how much potential energy it will gain at this height? mgh. So m is given 5, or g is given 9.8, or height you know 5 whole square, or 2 into 9.8, okay. So this 9.8 cancel out, or this is 5 into 25 by 2, so this is 125 by 2, or this is 62.5 joule, okay. So maximum potential energy gained by this ball is this much, okay. Hope guys, now the concept of energy, kinetic energy, potential energy are clear to you. Guys, if you think this lecture is informative for you and others, so please like and subscribe and share to your friends and family. In next lecture we will discuss about conservation of energy, power, and unit of electricity. And one more request guys, if you want to be updated for my next lecture, so please on your YouTube notification, so that when I will upload the next lecture, you will get the notification. So thanks once again for listening and watching this lecture. Have a nice day. Thank you very much.